Okay, so this comes from Northern Hemisphere, 2022 question number 8, and it's an integration by recognition question. You'll notice that the structure for that will be show this derivative, hence use your show to find the area bound by the graph and the horizontal axis. So the area they're wanting is this area here. And they've told you that it's between minus pi to 0. But for you to be convinced, we need to know what this x-intercept is. And it looks a little bit more than -3, doesn't it? Like -3.142. But if I set f of x equal to 0, then e to the x can't be 0. I'm looking for the sine of x to equal 0. And the graph of a sine of x is going to equal 0 on all of the pi's, including negative pi. So that is negative pi there. So the area I'm looking for is the integral from negative pi to 0 of e to the x sine of x dx, but that area, that definite integral will be a negative value, so I need to put a negative at the front to find the area. But I can't integrate that. We have a multiplication and x is in two different spots, which is why they're suggesting you use integration by recognition instead. So let's do that. In part 1, I need to show the derivative of this equals that, which means what I'd like to do is I need to do two separate integrals. So I've got u equals e to the x, which means u dash equals e to the x, and v equals the sine of x, which means v dash equals the cos of x. And I've also got u equals e to the x, so I've got a separate product rule, which means u dash equals e to the x, and v equals the cos of x, which means v dash equals negative sine of x. So d dx of e to the x sine of x minus e to the x cos of x will equal this times this, e to the x cos of x, plus this times this, e to the x sine of x, minus e to the x negative sine of x, plus this times this, e to the x cos of x, which gives me e to the x cos of x plus e to the x sine of x minus minus plus e to the x sine of x minus plus minus e to the x cos of x. These sum to 0 to leave 2e to the x sine of x, which is exactly what we're asked to show. So that's the first bit, show that the derivative of this equals that. So now that I've shown that, d dx of e to the x sine of x minus e to the x cos of x equals the integral of 2e to the x sine of x dx. I know that from this first line. If I was to integrate both sides with respect to x, then the integral of the derivative of the inside just equals the inside. So I know that e to the x sine of x minus e to the x cos of x equals that integral. But I don't want a 2 there, so if I could divide all that by 2, then that's what e to the x sine of x dx is like, which is exactly what I'm looking for. If I was to put a negative, then I could put a negative out the front. So I'm ready. Negative e to the x sine of x dx from minus pi to 0 is equal to, I'm going to bring the negative a half out the front and have e to the x sine of x minus e to the x cos of x from minus pi to 0. Negative a half, e to the 0 sine of 0 minus e to the 0 cos of 0. Then minusing, putting in the bottom terminal, e to the minus pi sine of minus pi, and then minus minus becomes plus e to the minus pi cos of minus pi. E to the 0 is 0, sine of 0 is 0, sine of minus pi is 0. Cos of 0 is 1, cos of minus pi is negative 1. So it gives me negative a half minus 1, because e to the 0 is 1, cos of 0 is 1. Then that's 0. There's a negative 1 there, so that's minus e to the minus pi, which gives an answer of a half, 1 plus e to the minus pi, acceptable. A half, 1 plus 1 on e to the pi, acceptable. Or you could express it as a half plus 1 on 2e to the pi. All of them are correct expressions for that area.